Hello and welcome back. So today's video, we are going to do a second case study on one of the questions I've discussed in my last video, which is the questions in the trial paper from the Terengganu. So let's review back what we have in the last video. So we have a circuit with 3 capacitors and 1 resistor connected in series. So I provided the solutions in my last video. So please watch it before you continue to watch this video. So let's see what we have from the last video. First thing we have that we have converted the circuit into an equivalent circuit with the new effective capacitance of 480 microfarads. So from here, we have derived the voltage response and also the current response in the circuit. So first, the voltage response is given as 24 multiply 1 minus E over negative T over 2.4 watt. And then the graph is shown here. So we also have the voltage response across the resistor, which is given as 24 minus the voltage across the capacitor. And then the next thing, we also have derived the expression for the current, which is 4.8 e to the power of negative t over 2.4 milliampere. And the graph response is shown here that the current reduced exponentially from 4.8 milliampere to 0. So we can raise a few questions on these questions. So I would like to expand the questions into more details that we can find in this case. So first of all, that the voltage response that we have obtained in the last video is the voltage response across the 3 capacitors. So we would like to find what is the final potential difference across each of the capacitor. And then we can find out what is the final charge on each of the capacitor. And lastly, we would like to express the voltage response and also the charge on each of the capacitor. So to solve all these 4 questions, so let us review back what is the calculations of the effective capacitance. So first of all, we have the capacitor network shown here. So we have 1,200 microfarad in series with the parallel of 200 and 600 microfarad, which you can calculate the effective capacitance on the parallel network of 200 and 600 into 800 microfarad. And then we calculate the effective capacitance of the 1,200 in series with the 800 microfarad into 480 microfarad. So these are the steps that how we can calculate the effective capacitance. So first of all, we look at the 480 microfarads. So we know that the final voltage across this capacitor is 24 volts. And the final charge on this capacitor is given as formula of CV, and you would get 11.52 millicoulombs. From the discussion just now, so we could see that the 480 microfarad is made of 2 capacitors in series, which is 1,200 microfarad and also the 800 microfarad. So please remember, in series network, we have constant charge. We have the same constant charge that the Q on the first and the second capacitor is 11.52 millicoulombs. And from this information, we can calculate the voltage using the formula of Q over C, where you would get 9.6 volt for the 1,200 microfarad capacitor. And then you also would get 14.4 volts on the 800 microfarad. Now we're going to look into the 800 microfarads. So what we have is that the 800 microfarad is made of 2 capacitors in parallel, which is the 200 and 600 microfarad. Once again, so please remember that in parallel network, we have the constant potential difference, which is 14.4 volt in this case. So the 14.4 volt is calculated from the previous network. Then we can calculate the charge on each of these capacitors. So first is the 200 microfarad, it has 2.88 millicoulombs. And as for 600 microfarad capacitor, it has 8.64 millicoulombs. So there's a lot of information we can get from this case. So let me do a summary on what we have here. So when the capacitor is fully charged, or when the current is 0, means the charging process is completed. Okay. So first, we have the final charge and the final voltage on 1,200 microfarad is 11.52 millicoulombs and 9.6 volt respectively. And then for the 200 microfarad, it has 14.4 volts and 2.88 millicoulombs. And then for 600 microfarad, it's 14.4 volt and 8.64 millicoulombs. So let us revise what is meant by capacitors in series and in parallel. So first of all, the most obvious thing is about the capacitor in parallel should have equal potential difference in the end. So we could see that both the capacitors of 200 and 600 microfarad, they have 14.4 volts when they are fully charged. And as for the capacitor in series, they should have the same charge. So if you add the 2.8 millicoulombs and 8.64 millicoulombs on capacitors in parallel, so you get the same amount of charge as 1,200 microfarad, which is 11.52 millicoulombs. Last but not least is about the 5,000 ohm resistor. So it has 0 volt and 0 ampere in the end. With all these informations, now we can express the voltage and the charge response on each of these individual capacitors. So first of all is the 1,200 microfarad. So we could have the voltage as 9.6 multiply the formula. And as for the charge, so we have the 11.52 multiply the formula. And then we repeat the same things for the next two capacitors. So we have 40.4 multiply the things for the voltage response of 200 microfarad, and the charge response would be 2.8 multiply 1 minus e over negative t over 2.4 millicoulombs. And as for the 600 microfarad, so you have these two equations for the voltage and charge response respectively. So the difficulty level of these questions may be a little bit higher, okay, but first of all, you need to understand the concept of series and parallel circuit. And then you should have already mastered the formula of Q, V, and I for the charging process of capacitor to solve these questions. So this concludes my discussion for today. So if you have any questions, you can ask in the comment section below. And also do leave a like on this video and subscribe my channel. I'll see you in my next video. Thank you.